again, Narek is here. Today I'm going to talk about linear inequalities, but in this case you will have a polynomial which is higher than first degree. You need to factorize it in order to obtain a product or a quotient of first degree, and then you will have to solve the inequality. Whenever it's a product or a quotient, you need to do a table of sign. So in this case we have a lot to study. We have to factorize, find the solutions, and then do the table of sign, and from table of sign we're going to choose the part which is necessary in order to solve the inequality. I'm going to take examples directly and we're going to solve them together. Let's start. The first one, let's say we had already a product which is x plus 1 times x minus 1 smaller than 0. Now, this is a second degree equation. It is factorized. Each factor is first degree, it's linear, but I cannot say x plus 1 smaller than 0 or x minus 1 smaller than 0. No, in this case I should take each step, each factor, and then do the table of sign. From the table of sign I will deduce the sign where I can have negative, which is smaller than 0. So first thing, you consider that this is an equation which is equal to 0, so you will have to say x plus 1 is equal to 0, which means x is equal to minus 1, or x minus 1 is equal to 0, so x is equal to 1. Now, these values, you're going to use them in your table of sign. Your table of sign will be formed by x going from minus infinity to plus infinity and passing through the values minus 1 and 1. Of course, minus 1 is smaller, that's why it's on the left side by referring us to 1, so minus 1 and then 1. Your first factor is x plus 1. Your second factor is x minus 1. And finally, you will have the product. Of course, you can write it down as p of x, or simply write it down x plus 1 times x minus 1. The first factor, it will be 0 for x is equal to minus 1. When x is equal to minus 1, your factor x plus 1 will be 0. What about on the right side of this 0? So it will be positive, positive, and on the left side it will be negative. How do I know about the sign? Very simple. Let's choose a certain value of x greater than minus 1. Let's say it was 0. And replace 0 in this factor. 0 plus 1 is 1, it's positive. Let's take another value, 3. 3 plus 1 is 4, it's positive. So either you have to check by taking some values greater than minus 1 in order to know the sign after 0, or you can choose, you can check your factor, which is x plus 1. The coefficient of x is 1, it's positive, that's why on the right side of the 0 it will be positive. Alright, let's do this, the same thing for the second factor, x minus 1. So x minus 1 will be 0 for 1. What sign will I have on the right side? It will be positive, since the coefficient of x minus 1 is plus 1. On the left side it will be negative, negative. The product is minus times minus, plus 0 minus 0 plus. So in this case I have the sign of the product or the whole polynomial. Now I have to choose the part where it is negative. So I want negative, I will have to choose the negative part. So s will be equal to minus 1 until 1. This is how you solve an inequality where you have a sign, where you have a product. All right, let's take a new example. What about this case? 8 minus x times x minus 2 greater than 0. All right, again, the first step is to consider it as a simple equation. So you will have to say its factorized form. It's easy to solve. So you will have to say 8 minus x is equal to 0, x is equal to 8, or x minus 2 is equal to 0, x is equal to 2. All right. Now from this, I will have to do the same table of signs. So x going from minus infinity to plus infinity. The values are 2 and 8. The first factor is 8 minus x. The second factor is x minus 2. And then you have the product, which is of course 8 minus x times x minus 2, which you can write it down as p of x. Alright, 8 minus x will be equal for 8. On the right side, you have to check the coefficient of your x. So it's minus 1. So it will be negative, positive, positive. X minus 2 will be 0 for 2. You have to check the sign of the coefficient of x. It's positive, so positive on the right side, negative on the left side. In case you want to take values, no problem. Let's say I took x is equal to 0, which is smaller than 2. I replace 8 minus 0, it's positive. X minus 2, 0 minus 2, it's negative. So plus, minus. What about the sign of the product? It's negative, 0, positive, 0, negative. I'm looking forward to find the positive value, so it's only this case. So s is equal to 2 to 8. All right, let's take another example where we have a quotient or a rational form. What about this case? 2 minus x times x plus 3 over x minus 4 greater or equal to 0. You start, again, you have to start by saying that 2 minus x, it's good, we have 10 there. 2 minus x is equal to 0, so x is equal to 2, or x plus 3 is equal to 0, x is equal to minus 3, and you have to say that x minus 4 should be different than 0. The denominator cannot be equal to 0, so x different than 4. And you add all these values in your table. So x going from minus infinity to plus infinity, the values are minus 3, 2, and 4. The first factor, 2 minus x. The second factor, x plus 3. The third factor, x minus 4. And then you can say it's the quotient q of x. Now, in order to not forget, 4, it's a value which is shaded because it's a value that I should reject. What about minus 3 and 2? They can be normal values. So 2 minus x will be 0 for 2. On the right side, it will be negative, negative. Why? 2 minus x, the coefficient of minus x is minus 1, so it's minus, minus. In this case, it's plus, plus. X plus 3, it's 0 for minus 3. positive on the right side, negative on the left side. X minus 4, it's 0 for 4, but of course it's shaded, and then positive on the right side, negative, negative, negative on the left side. So Q of X will be positive, 0, negative, 0, positive, shaded, negative. I'm looking forward to find positive or greater or smaller than 0. So my solution will be from minus infinity to minus 3, union from 2 till 4. All right. What about taking one last example? So let's take one last example. X squared minus 1 times x squared plus 1 over x smaller or equal to 0. All right. Again, I start by solving. X squared minus 1 is equal to 0. So x minus 1, x plus 1 is equal to 0. X is equal to 1 or x is equal to minus 1. X squared plus 1 is strictly positive. It will not be equal to 0. And x should be different than 0. So I will have to do the table x from minus infinity to plus infinity, passing through the values minus 1, 0, and 1. The first factor, x minus 1. The second factor, x plus 1. The third factor, x squared plus 1. The fourth factor, x. And then Q of X, the quotient. 0 is shaded. Why? Because it's a value that I should reject. What about minus 1 and 1? They are acceptable values. So x minus 1 will be equal to 0 for 1 plus negative, negative, negative. X plus 1 will be equal to 0 for minus 1 plus, 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 negative. X squared is always positive. It will not be even equal to 0. It's strictly positive. And x is 0 for 0. It's positive on the right side, negative on the left side. What about the quotient? It's negative times negative plus, plus, negative. 0 plus shaded, negative, 0 plus. So I am looking forward to find the part where it's negative or equal to 0. So my solution will be S from minus infinity to minus 1, union from 0 to 1. Again, the brackets are closed. All right. That's all for this video. Why don't you subscribe to my channel? You'll be notified whenever I upload new videos. And I can also share with you my Instagram and Facebook account. You can contact me or you can leave a comment below. I hope it was helpful and see you next time.